The Burj Khalifa, a triumph of modern engineering, rising over 800 meters above the desert.
From the ground beneath the desert to the tallest structure ever built, this is how the Burj Khalifa was made.
Check the grid pattern on the north side.
Coordinates logged. Drone looks stable at 50 meters.
Look at the stratification here. The density changes right at this layer.
Yes, I'm noting it.
Yes, I'm noting the reddish tint and the compaction.
Final pressure reading is stabilizing at 450 psi.
Noted. We can move on to the next set.
By 2007, the structure was rapidly taking shape. The final spire locked into place in 2010.
Look at the vortex shedding behind the structure. The turbulence is exactly as predicted at this wind speed.
Yes, the data on the screen confirms the drag coefficients.
How does the wind load analysis affect the higher sections?
We've adjusted the core, but the tapering remains the critical element here.
As you can see, the buttressed core effectively transfers the loads down to the foundation.
And the connection detail at the transfer level?
It seems robust.
We need to verify the steel structure on level 4.
The model shows it's aligned, but let's double check the measurements on site.
4 power, move it straight ahead. Woo!
The reading here seems consistent with the plan.
Yes, the deviation is within tolerance.
All units maintain synchronized pace. We are clearing the east section on schedule. Over.
Compare the gauge reading with the projected settlement.
It aligns with the compaction curve, ma'am. We are good to proceed.
Check the pressure gauge readings against the report.
The data aligns, but this section requires further testing for compliance.
The flow rate is increasing rapidly. We have significant saturation here.
Agreed. Initiate the dewatering pumps now. This can't wait.
Easy on the tension. Watch that line.
Flange secured on this side.
All right, set her down. Looks good.
Ensure the tension is correct on the main brace. We need full stability on the slope before the next pour.
We need to adjust the depth over there.
According to the schematic, the pipeline runs right under this spot.
The depth gauge is reading exactly 12 feet.
Verified against the schematic, we are clear to proceed.
Increase the rotation speed slightly. Copy that, adjusting the flow rate now. As you can see, the diameter of this board pile is significant, measuring 1.5 meters across, highlighted here in comparison to the engineer.
Look at the consistency in the lower strata.
Yes, the installation looks good all the way down to 50 meters.
The verticality is stabilizing now.
Good. Maintain that pressure until it locks in.
This waveform suggests a localized anomaly in the sonic echo. I agree.
The transient response indicates a stiffness reduction at 20 feet.
.007 is done.
Noted. Status updated.
Check the displacement at the current load. It's exceeding the limit.
Confirmed. I'm noting the exact time and reading.
Another bundle of 25s on the east side.
Copy that. Sending the crane over now.
Next truck is ready for position 3. Make sure the flow rate is steady. Keep it coming. Watch the pressure. We need the next one lined up immediately.
The internal gradient is stable at 0.12.
Good. The ice slurry is maintaining the required flow rate. All right, day shift. We're taking over. Keep that pump steady. Levels are good here. Watch the vibrator on the far side.
Roger that. Moving in now.
The core temperature is stabilizing nicely. Yes, the cooling blankets are working as expected.
Everything is within the acceptable range. The markings are clear.
Agreed. We can issue the approval certificate this afternoon.
All right, bring it down 5 meters. Hold it there, we've got a strong gust coming in.
As you can see, the core wall is extremely thick, 1.3 meters exactly.
And the reinforcement layers are incredibly dense.
Built to last. The flow rate seems high over here.
The tablet says we're within range, but I'll signal them to slow the pump down slightly.
We have green across the board except for this section here at Station 4.
I see the amber deviation. Rescanning now to verify the alignment. Does that match what you have on the tablet for the service opening? Yes, it's exactly 12 feet. We are good to proceed with the pour on this level.
Structural frame progressing.
Hold the line steady. Watch the wind on the east side. All right, slowly lower it down now.
The post-tension system provides the structural strength needed for a building of this scale. The cables must be aligned with
sequential floor construction.
The typical floor height of this skyscraper is designed at 3.9 meters, providing
The clearance here matches the specifications. Let's double check these beams against the schematic. Condition red, high winds. Everyone hold on. Copy. Securing now. Crane coming down. Danger zone.
tapering structural frame. This design creates unmatched structural efficiency by reducing mass as the building rises.
The highest crane operations in the world, pushing the limits of engineering. Extreme height, extreme precision. Watch your step, up there.
Clamp is tight.
Netting secure. We are good to proceed.
The Burj Khalifa rises from the desert, an engineering marvel in progress. The concrete pumping in progress.
Keep it steady. Guide it to the center.
Watching the flow. Watching the float.
Ready with the float.
Keep it moving on the right. Level it out fast. Watch the hose, we're almost done here.
We're approaching the limit.
I see it. Rerouting the pressure valve.
Keep it steady. Guide it slowly. Alignment is critical here. Just a fraction more to the left. Confirmed. Engaging suction. All right, hold it steady right there. Got it. Hitting the first bolt now.
Align the laser.
It's set.
Secure the bolts.
looks good. All heads activated within the required time frame.
Agreed. Test passed.
Cable check complete on P1. Adjusting gain on P2. Looking good. Status green on upper conduit.
Easy now, easy. Hold it right there.
Looks aligned. Starting the bolts.
Secure the corners first.
Vibration damping is excellent at target speed.
Confirmed. System holding steady at 10 meters per second.
All systems are green on the main panel. Confirmed here. The environmental controls are stabilized.
Looks like we're ready for commissioning. Great work, everyone.